Good afternoon, everyone, and welcome to our 2025 Summer Outlook for the UK and Europe. My name is Andrea Berg, and I will be your host for today. I just want to start off with some housekeeping. We are recording today's webinar, and we will send out a link to the recording in approximately 5 days, probably early next week. So if you want to share this with any of your colleagues or want to rewatch it, that will be available. If you're experiencing any technical difficulties at any point during this presentation, just use the chat feature on the right-hand side of your screen and message the host, and I will help troubleshoot. In addition, at any point during our presentation today, if you have any questions, please use the Q&A feature on the right-hand side, and we have saved some time at the end to go over any questions. So with that, I would like to introduce my colleague, Stephen Davenport. He is one of DTN's long-range risk communicators, and he will be taking you through our presentation today. Stephen?
Thank you very much, Andrea. Good afternoon or morning or evening, wherever you may be watching. As Andrea said, I'm Stephen Davenport, Long Range Weather Risk Communicator at DTN. And here's what we'll be looking at today. First, a review of last summer, what we've seen so far this spring, a glance at how we put the forecast together, and then a medium range outlook for the next few weeks into May. Then the seasonal influences on this upcoming summer's conditions, plus the global seasonal model output, and we'll tie those all together for the official DTN forecast. Then it's worthwhile having a look at the tropical outlook and what impacts that might have later this summer, and we'll wrap up with what impacts there might be on various industries. So let's start with a reminder of 2024 summer, starting with the temperatures month by month. The pattern was an interesting one and something to look for when we get to this year's forecast as well. Looking at the chart on the left, you can see the jet stream pushed northwards with weak flows across northwest and northern parts of Europe, with a rather blocked pattern across the European continent, and indeed a split jet with a branch shooting southwards at times across southern Europe. And now this all resulted in warm flows at the surface across Eastern Europe, but temperatures closer to average, as you can see in the right-hand graphic, for most of Central and Western Europe. It also meant a lot of wet weather across much of the continent. In July, a change in the pattern with a more standard, I suppose, jet stream configuration, quite strong across the northern half of Europe, maybe a little further south than average. So warm to the south and east of that jet, and particularly hot and dry in southeastern Europe, while much of western and northwestern Europe had near average temperatures, periodically wet conditions, with the jet enabling a sequence of Atlantic low pressure systems to develop and move across. Finally, for August, strong jet stream again, but pushed further north as high pressure expanded more across Europe. And this allowed warmer than average air to become more expansive, with seasonal temperatures for northwest Europe just getting squeezed out there, above average temperatures for much of Europe. Low pressure tracks shifted further north of the jet stream, so Western Europe became less wet as well. Here's what the precipitation anomaly pattern looked like month by month, with those very wet and locally stormy conditions across parts of Central, Western and Southwestern Europe during June due to that split jet regime. Dry trend overall through the rest of summer, especially for Western Europe, although Southwest and South Central Europe had locally wet areas with localized storms. Putting all that together, we can see it was hot and dry summer for Southeast Europe, where it's been a struggle to wipe out the dryness even through this past winter. While it was wet from Central to Southwestern Europe, near average or a little drier for the UK and Ireland. Wind was above average from the northern UK to southern Scandinavia, near that jet, but much of Europe had rather poor winds and slightly below average solar, although there was good solar for Southeast Europe, poor for the northern UK. And zooming in on the UK, there's a lot of temperature variability, but that really washed out across the season with temperatures overall near seasonal. Western Scotland and the far northwest of England, you can see on the right there, were a bit wetter than average, in stark contrast to the rest of the UK, which was drier or near normal in terms of precipitation. And here you can see that variability in graphical form. No lengthy warm periods, but with the position of the jet stream, some cooler outbreaks occurred with flows from a more northerly direction. Then the stronger jet stream in August brought more westerly flows with shorter, cooler interludes. Well, that was last year. What about the summer of 2025? What might be different or indeed similar this year? Well, unlike last year, we're most likely to have a neutral ENSO regime in the equatorial Pacific. More of that later. It's the El Nino Southern Oscillation, and we'll dig into that during the subseasonal and seasonal forecast. Last year, we had El Nino weakening into a neutral regime, while this year we've seen a weak La Nina early this year, trending to neutral conditions currently and expected to stay that way through the summer. The North Atlantic Oscillation, the NAO, should be positive more often than not. We might more frequently see a north shifted or even split jet stream. The Atlantic's a bit less warm than last year's record warmth, but still expecting sea surface temperatures to be above average, while the North Pacific retains a similar pattern, the long-lasting negative Pacific Decadal Oscillation. And more recently, what's the weather been up to across Europe? Let's take a look back to February. That was warmer and drier than normal across a whole swathe of Europe, thanks to a blocked and high pressure dominated pattern. The UK and Ireland, as you can see there on the left, were closer to average temperature wise, while Ireland was very wet, as you can see from the precipitation anomalies on the right there, with sluggish low pressure in the East Atlantic, which made it wet for Portugal and parts of Spain as well, especially the northwest. The southern half of Italy was rather wet as well due to slow-moving cut-off lows lurking around the central Mediterranean. Moving on to March, blocked pattern continued. It's worth a look at the jet stream pattern, both northward shifted and split with a branch heading towards the Med and Africa, similar to what we saw earlier for parts of last summer. And this is going to become a bit of a theme as we move through this presentation. At the surface, this was the pattern that this led to, with high pressure anomalies from northwestern Europe towards southeastern Europe, splitting low pressure systems to the far northeast and near or just west of the Iberian Peninsula, where there were some deep and sluggish low pressure systems. And this setup brought some significant and impactful weather, as these temperature and precipitation anomaly charts show. Eastern Europe was warmer or much warmer than average, but perhaps more notable is the very high amount of precipitation in parts of Portugal and Spain, with those frequent, long-lasting, sluggish, slow-moving storm systems. So there were some severe storm outbreaks and flooding rain, and some very wet conditions spread to northern Italy at times as well, with those cut-off flows across the Med. Meanwhile, though, with the high pressure influence, much of central, western and northwestern Europe was drier than normal. Another way of looking at the same thing here, with more details showing that more wetness across southern Europe and the strength of the warmth over eastern Europe, where there were some local records broken. And for the month overall, some areas were 6 to 8 degrees above the average. It's worth looking at how dry it is across parts of Europe while we're at it, and while we're looking at recent rainfall. Here's the position through March, with worsening conditions in places and a severe outlook in place for parts of the Mediterranean and Eastern Europe. Southeast Spain might be a bit surprising given what we've just seen, but the winter and spring were very variable, switching between very dry and very wet conditions. And this dryness has significance to the summer forecast once we get there. If the soil stays dry, then air more readily heats up, feeding back into the expected high pressure blocking patterns, which would then further exacerbate the aridity. So this will bring threats to agriculture with impact for heat wave risks, heat spikes, and elevated chances of further drought and wildfires. Having said that, some areas could end up with excessive rain. It's the very nature of these kinds of blocked patterns. So some areas further away there are potentially again down in the Iberian Peninsula could be seeing some rather wet conditions developing. But we'll see that later. Just for what it's worth, a quick glance at recent dryness in southern England. This is specifically near the Salisbury area, where the spring has in a few spots been the driest so far in recent decades for March and April so far. Now onto our forecast, and first look at what we call the subseasonal range, which takes us through the next 3 to 4 weeks. First thing to consider is the climate factors having an influence of this range. First, well, this is both a subseasonal and a seasonal driver, the El Nino Southern Oscillation. That's the warming and cooling of the equatorial Pacific, varying between El Nino and La Nina and through neutral ENSO conditions. And it's neutral ENSO that we're looking at having for the next month, and we expect longer than that as well. We also have warmer than average waters in the North Atlantic, not as warm as last year at this time, but still above average at the moment and expected to stay above average. In addition, you might recall a sudden stratospheric warming event and stratospheric polar vortex disturbance in February and March, which still has some lingering influence on the blocked position and a cold outbreak across Russia currently and in the short-term outlook. The MJO, the Madame Julian Oscillation, that looks weak and not all that influential. But we should see the NAO, the North Atlantic Oscillation, trend from slightly negative to neutral or slightly positive with a rather blocked pattern underlying, with high pressure across Europe downstream of lower pressure near Greenland and Iceland. I mentioned the MJO, the Madame Julian Oscillation, so just a quick explanation of that. It's one of the main influence of global weather patterns in the medium range, a regular pulse of tropical convection and thunderstorms that circumnavigates the globe eastwards through an average of about 28 days. Now, if strong enough, this convection can alter tropical circulations as shown here, with knock-on effects even in distant parts of the world, altering the shape of long waves into the mid-latitudes. These graphs might not mean too much, a bit technical maybe, but some of you will know what they're about. But they're one way of tracking the MJO and its forecast path and strength through these real-time multivariate indices. And it's ECMWF on the left and Australia's Bureau of Meteorology on the right. The MJO moves through number of phases, 1 to 8 for different parts of the oceans, but notice in both these forecasts it's not predicted to attain much strength, so its impacts in the next couple of weeks or so should be rather limited. Other climate drivers will be delved into a bit more when we get to the seasonal outlook. Meanwhile, here's a way of looking at the expected pressure pattern regimes. It's the forecast regime frequencies from the ECMWF ensembles, taking us right into June. Now, the red columns are most prevalent through to the start of May, and these represent the blocked patterns we've already mentioned, which should manifest as high pressure somewhere over mainland Europe or Scandinavia. Now, as we go further into May, there are greater bold probabilities emerging of an Atlantic ridge pattern. That's the purple columns, which implies chances of high pressure ridges shifting further west, potentially leading to some cooler air at times into some parts of Europe. Nothing excessive expected, and it shouldn't last though, with blocked scenarios growing in likelihood by mid-May again, with some growth in possible positive NAO solutions mixing in positive NAO indicated by the blue columns there. Negative NAO is a low risk, so warmer than average conditions will become more likely than cooler again, and there's a low risk of any notable coolness or cold conditions as we move through late spring. Here's another way of looking at that. Not too confusing, I hope. This is from the ECMWF ensemble again. It shows from left to right, the 8 to 14 day forecasts, 15 to 21 day and 22 to 28 day forecasts. It's the probability distribution of blocking, anti-blocking, and positive NAO and negative NAO. Positive blocking implies high pressure over Europe or Scandinavia. Negative blocking would mean high pressure further west in the Atlantic. This cooler risk that we talked about. Positive NAO is high pressure near the Azores, low pressure around Iceland and Greenland, and a negative NAO, the opposite, with high pressure building around Greenland, forcing the jet further south and allowing for cooler outbreaks. And the spread's quite wide here, but mostly we're seeing a mixture of positive NAO and positive blocking favored. So that implies mostly warmer than average conditions through the next 3 to 4 weeks. In fact, we've got some really very warm conditions coming up as soon as next week. Another visual here, these are the 5-day average pressure patterns at the 500 HPA level from the ECMWF ensemble, and through to early May, you can see high pressure anomalies dominating across Europe in a rather blocked pattern, the shape we call an omega block. You can probably see why. Note also the cutoff low pressure lingering near Portugal, just to the west, and in far southeastern Europe. Then moving through the following 5 days on the right, you can see that possible Atlantic ridge development as the pattern shifts and retrogresses a bit westward. So some slightly cooler air as mentioned, but nothing significantly cold. And as we've seen, that setup shouldn't last too long. Onto the sub-seasonal forecast itself, I thought I'd share snapshots of pages of our regular sub-seasonal report, which is available twice a week. And next week, which is week 18 of the year, has a warm look to it, as I just mentioned, across much of Europe. But there's also that colder plunge east of the blocking high pressure across Eastern Europe and Russia, if you look at the map of temperature anomalies. We compare the ECMWF and CFS V2 models, and although both show a similar pressure anomaly pattern, the CFS V2 has deeper and more widespread cold across Eastern Europe. Having said that, the ECMWF is preferred here, more in line with the slightly positive NAO pattern expected to develop. And from the table above the chart, you can see we're expecting temperatures overall for the week as much as 4 degrees above average for the UK and Ireland and for France. Parts of the UK, we're predicting maximum temperatures up to the mid to upper 20s in places. 27 degrees is showing up here and there, could hit 30 in the near continent. And as far as precipitation goes, so that peak temperatures, I should say, for the middle of next week. For precipitation, both models showing widespread drier than normal conditions with rain-bearing systems generally forced southwards across Iberia and around the Central Med. Just remember those cut-off low-pressure systems. The following week, week 19, that has that Atlantic ridge pattern showing up, more marked in the CFS V2 pressure anomaly forecast chart than the ECMWF. You can see the impact on temperatures with the warmth moderating closer to normal for most areas, or 1 or 2 degrees above average at best, perhaps. Note that very cold air still pouring into West Russia in the CFS V2 outlook, but a big difference with the ECMWF, which looks a little more probable. However, risks are to the cooler side of the forecast. Some wetter weather maybe could edge into Western Europe and the southern UK, but conditions should remain wettest across the Iberian Peninsula and possibly parts of the Central Med. Week 20 takes us through the middle of May. There are still divergent patterns across the models with weaker pressure anomalies showing in the ECMWF outlook and no dominant pressure regime, whereas the CFS V2 has stronger high pressure over Scandinavia and also the central Mediterranean with low pressure showing up more near Greenland. That's the positive NAO pattern. Near to above average temperatures are still most likely, but again only 1 to 2 degrees above normal at warmest, while southwest Europe, Iberia Peninsula remains wet with temperatures subdued. And some wetter and cooler weather could be trying to get into parts of France and towards Central Europe. You can see the temperature trends here, both past and forecast. These are from the next page of our sub-seasonal report for various countries and regions. You can see the warm bump up in temperature and then a cooling towards normal. By the way, if you want to get your hands on these reports, then just let us know. We'll be happy to set you up with a trial. I'll look further ahead through the summer. So start to take a look at the seasonal prospects. The first thing, what goes into the forecast? Well, it's compiled by taking the long-term climatology, narrowing that down to trends over the past decade, then relating that to the statistical analogs from the teleconnections and some of the seasonal computer models to create our final forecast solution. Firstly, the teleconnections, what they are and what they do. Now, teleconnections in weather refer to significant relationships or links between large-scale weather patterns and circulation anomalies at locations far apart on the Earth, often across vast geographical areas. And these patterns, like the El Nino Southern Oscillation, ENSO, can influence temperature, rainfall, storm tracks, and jet stream location over large regions. Climate events in one area can have a domino effect on weather patterns much further away. And some of the most significant teleconnections are related to sea surface temperature anomalies around the world, first among these being the ENSO, the slow temperature anomaly variability in the equatorial Pacific, which swings between El Nino and La Nina, that's warmer and cooler seas. We're currently going through a neutral phase following a weak El Nino, late winter and early spring. It has kind of a weak influence on Europe, while the Atlantic Multi-Decadal Oscillation, the AMO, which measures warmth in the North Atlantic, is likely to be more influential this year. So the North Atlantic has been warm for a long time, meaning a positive phase of the AMO, which will continue this year. It's not going to be as warm as last year, though, which had some record-breaking sea temperatures in the North Atlantic. Meanwhile, over in the North Pacific, we've got the equally long-lasting PDO, or Pacific Decadal Oscillation. This is a pattern of warm waters across the North Pacific, but cooler sea temperatures in more or less horseshoe band towards the western coasts of North America. One final feature is the Indian Ocean Dipole, or IOD, which slowly swings between positive and negative phases in a similar fashion to the ENSO in the Pacific. The positive phase has warmer waters in the western Indian Ocean than the east, and vice versa. But this year, we're more likely to stay in a neutral setup for much of the time. These diagrams might give you an idea how ENSO changes can influence circulation patterns, and top left there is La Nina, which gives us rising air and strong convection in the western Pacific, descending air in the eastern Pacific, and during El Nino, the reverse, more or less, as the right-hand bottom diagram depicts. Now, comparing La Nina and neutral ENSO conditions, the differences are not as great, but convection tends to be less strong with weaker impacts on distant circulations. Now here's an unadorned look at the current global sea surface temperature anomalies, and this is as of 22nd of April, so just a couple of days ago. Currently warmer than average across the North Atlantic, but some cooler areas have emerged, most notably a narrow line off the eastern seaboard of the US, where low pressure systems have tracked. The negative PDO shows up well with very warm waters in the central North Pacific and cooler seas towards the North American coast. Indian Ocean is warmer than normal, but more or less equally warm west to east, hence the neutral IOD. So global sea surface temperatures, as a result, much warmer than average, as you can see here on the left. That's the global global average. Currently the third warmest on record, behind only last year and the previous year, 2023. Looking at specifically at the Atlantic on the right there, it's more noticeably cooler overall than in 2024, although still above average overall, with a positive MAO regime expected to last some of the most of the cooling compared with last year's down towards the tropics rather than in the northern parts of the North Atlantic. It might come closer to average before temperatures pick up again through May and June. The anomaly is expected to increase again. And we'll have a little discussion about that later when we come to the tropical section. To summarize, and so we're most likely to have neutral conditions as noted through the summer in the Nino 3-4 region, the Central Pacific. So there's been some warmth lingering in the 1-2 region near the South American coast. Impacts in mid-latitudes are rather uncertain, but may still be a little La Nina-ish following the late winter and early spring weak La Nina episode. It's interesting to look at the forecast from last October. It did have a La Nina condition forecast for the late autumn and winter. It happened, but the problem was it developed later than models were forecasting from December to February, which threw a bit of a wrench into forecasts, so, although more so for North America. The most recent ENSO forecasts clearly show the average of many model outcomes, keeping ENSO well within neutral bounds. This is the compiled forecast from the International Research Institute, average of the red line for the dynamic forecast and green line for the average of the statistical forecasts. And we can see a few outliers dipping into La Nina territory in the forecast and just one or two trying to push towards El Nino. And that was the forecast issued in March. And here's the latest issued in April, just to show the forecasts are quite consistent. But having said that, there's a bit more spread and uncertainty in this April forecast, with a few model members diverting more towards either El Nino or La Nina states. So this does shows some uncertainty, although most solutions are still camped in the ENSO neutral territory, as are the model averages. Here's another way of looking at the ENSO forecast, this time from NOAA's Climate Prediction Center. Although chances of a return to La Nina grow through the rest of the year incrementally, ENSO neutral conditions are remaining most probable even into the winter. Any kind of El Nino development is very unlikely, especially as El Nino statistically doesn't really develop that late in the year. Anyway, that'll be more of a matter for the next winter forecast. Strong trade wind surge took place in the Eastern Pacific between the 13th and the 18th of April. That's those yellow areas on the right there. That significantly cooled the Eastern Pacific, but we've had a return to westerly wind anomalies since. That should allow temperatures in the ENSO 3 and 1.2 regions to rise again. That's the forecast of the upper ocean heat anomalies on the left here is showing. Westerly winds are expected through the next 2 to 3 weeks. The temperature volatility can be expected going into the summer. A couple of westerly wind bursts occurred in late March, again in mid-April in the Western Pacific, which could be a step towards warming the tropical Pacific through their coming weeks. And easterly winds look like returning to the Central Pacific around mid-May, which should subdue any warming trend in the Central Pacific. There's volatility continuing in the ENSO guidance beyond July, but we're still looking at a cool ENSO neutral or even a weak La Nina developing again later in 2025. Here are the large-scale patterns generally associated with phases of La Nina and El Nino. Right-hand pair is what we're interested in for early summer. You can make out maybe that El Nino would lead to an active and wet pattern across the northern half of Europe, with southern Europe having dry conditions, but we're not expecting El Nino at all. El La Nina or even ENSO neutral would be more favorable to somewhat drier and more high pressure dominated conditions across most of Europe, with a lot of warmth in the east. And this is what we're expecting from both analogues and seasonal model output. With rather weak signals from some of the main seasonal climate drivers, we need to look for other clues and for the most likely summer setup. One of these is the North Atlantic Oscillation, the NAO, as already mentioned, a measure of the difference of pressure between Iceland and the Azores approximately, with low pressure anomalies in the north and high to the south being a positive NAO, and the reverse being true. This can be highly significant in winter when a negative NAO often leads to notable cold outbreaks across parts of Europe, but There can be impacts in the warm half of the year as well, so identifying the nature of the summer NAO or SNAO can be helpful. Cooler air can move across if the SNAO goes negative as the jet gets shifted further south. That can also make parts of Europe abnormally wet. On the other hand, a positive SNAO means a northward shifted jet and frontal zone pushing low pressure tracks further north, allowing dry weather across northern Europe with widespread warmer than average conditions. But it can lead to some weaknesses further south and chances of a split jet, which we've already seen, a recurring theme. That could lead to some wet and stormy conditions inland around the Mediterranean, eventually maybe later in the summer. We think that positive SNAO is a little more likely at this stage, but why? Well, we can get some idea from springtime circulations and at least look at the whole of March for some clues. It's kind of important to note that we've seen similar configurations with block patterns and split jet streams in winter and early spring, which have led to unusual and prolonged periods of drought, for example. The memory of the North Atlantic jet stream could play a role in the coming summer with increased risks of persistent extreme weather, which I just touched on a few minutes ago, such as drought and heat waves in Eastern Europe, for example, but flood risks in peripheral areas, maybe including the Iberian Peninsula, which would be in line with persistent long wave troughing in the Eastern North Atlantic. There's an illustration what I was talking about a short while ago. On the left, a negative SNAO regime with high pressure over Greenland and Iceland, forcing weather systems and cooler and wetter conditions further south. On the right is the positive SNAO situation, low pressure across Greenland and near Iceland, and stronger high pressure across the mid-Atlantic and Europe. Now, we saw this earlier, but here's a reminder of the upper level pattern we saw in March with a split jet, the northern arm of which displaced further north than average. And that's why much of Europe was so dry, but also why along the southern limb of this split jet, very wet conditions prevailed across much of Iberia and parts of the Med. Now we can utilize this as an analog if we can find similar years to March 2025, and it so happens that there are at least a couple of years with such a split and north shifted jet during March, and two of those were 2012 and 2022. These are already among our analogs for 2025 for other reasons and got promoted closer to the top. So let's take a look at those analog years, apply them to July. It shows a northward shifted jet, but and an AO, but would also come with some hints of a risk of a split jet with an active period in the Mediterranean. We can look back further, in fact, to see why the March pattern happened in the first place, and the blocked setup we've been experiencing has at least a few roots in the behavior of the stratospheric polar vortex during late winter and early spring. There were disruptions to the polar vortex and a big hit during March with a major sudden stratospheric warming. This may have helped the spring blocked patterns to develop, especially as the vortex remained weaker than normal during April. So it's kind of interesting that the wintertime phenomenon might have an influence months down the line into the European summer. So there are various reasons to expect above average warmth for much of Europe this coming summer, or at least for warmth to be more probable than cooler than average conditions. As this forecast for June, July and August sea surface temperature shows, there's a continuing warm phase of the AMO, the negative phase of the PDO, as we've just seen, the expectation of a positive summer NAO, albeit with those provisos for Southern Europe at times, the risks of occasionally wetter and cooler weather in parts of Southern Europe and the Med. The neutral ENSO should have low influence, but at least doesn't favor any cool or cold weather in general. Now, cool weather might be a risk if the Atlantic fails to stay as warm as expected, or if blocked patterns shift further west, which they might temporarily do at times, as we saw in the subseasonal outlook. The risk is that kind of becomes more persistent, or if we see a negative NAO, Greenland high pressure or Atlantic ridge more often. Just a reminder there, the AMO and the North Atlantic sea temperatures. And as long as those temperatures remain above normal, we can glean this correlation, which is positive correlation between positive AMO and 2 meter surface temperatures across Europe. And finally, Yes, for it's worth a quick glance at the forecast for the Indian Ocean dipole. Approached a positive state recently, but it's returned into the neutral phase. And through the summer should stay neutral or edge towards weakly negative. And that has a relatively small input into a forecast. So here are analogues, which the best we can are years that reflect similar ocean temperatures and circulation patterns to those we're expecting this year. It's often tough to find sufficient years, especially given the changing climate. This year was no exception, but we came up with a top 10. And our logs are based on the expectations of a neutral ENSO, positive AMO, negative PDO, with minimal weight to the central IOD, I'm sorry. And as already mentioned, a couple of good analogues for March circulation patterns were 2022 and 2012, and these were pushed up the list. So here we go, breaking down the summer into months, starting with June. The analogues suggest above average temperatures, especially in southern and eastern Europe, along with below average rainfall, but closer to normal in northwest Europe, where analogues also depict some wetness. July looks drier than average over a wider area with a similar temperature anomaly pattern. A north shifted frontal zone and low pressure track would take wetter and cooler conditions across northern parts of Scandinavia, maybe central Scandinavia. But some strong heat and drought would be possible for parts of southeast and eastern Europe. Note that the precip there for the Iberian Peninsula is near normal, so maybe some suggestions of some wetness there. It's a little bit washed out at this range, but those risks, as previously mentioned, for systems to get stuck near Iberia and produce plentiful rain and storms. A change in August, if you recall, we mentioned chances of a stronger jet in a position closer to climate averages. So that could mean some wetter conditions across northern and northeastern Europe and temperatures closer to normal, although still looking above average according to the anomalies, the analogues across southern and eastern Europe. Overall then, this would mean above average temperatures for much of Europe for the June to August period, although North and Northwest Europe would be closer to average. No signs of any noticeable coolness, though dry for southern and parts of southeastern Europe, unless the possible split jet manifests. But those are the analogues. That's not all we'll be looking at. We can't just rely on those. These need to be combined with the seasonal forecast models for the full picture. We use predictions from several seasonal global models, but notably the ECMWF and the CFS V2. So first up's the ECMWF, lots of orange and red showing each month from May right through to August in the temperatures. Some seasonably cool and wet conditions for Spain in May, while Scandinavia, according to the ECMWF, has its warmest anomalies during May and its coolest during July. Now note the dryness across much of Europe, especially the east and south during July, even into August, and that's consistent with what the analogues are suggesting as well. Wind output doesn't look too good, even given that it's summer. Some increases at times across northern and northwestern Europe, but generally near or below average. Sea level pressure patterns are a bit washed out, but do show high pressure dominance during May and chances of a more westerly regime in August. CFS V2 model doesn't look too different, but there are certainly some variations. May in particular looks cooler, especially for Eastern and Northern Europe and Western Russia, which actually ties in with the colder chances it showed in the sub-seasonal forecast. It also keeps cooler conditions over Spain, probably too persistently cool, but there's some veracity if the block patterns develop such that low pressure systems tend to get locked in near the Iberian Peninsula. Otherwise, a lot of above average temperatures across Europe and dry weather for parts of Eastern and Southeastern Europe, except for the far southeast at times. As with the ECMWF, the block patterns don't do any favors for wind output, especially during June and July, although some show some chances of increases, especially across northwestern Europe during August, related perhaps to a more energized Atlantic jet stream. More model guidance comes from the C3S multi-system seasonal forecast, which derives its output from a spread of 8 major global seasonal models. This also shows us above average temperatures for the summer as a whole right across Europe, although closer to seasonal for parts of southwest and northwest Europe. The precipitation forecast has drier than normal or near normal conditions across most of Europe, but enough of a low pressure track to give some wetter conditions from Scotland to western and northern Scandinavia. Now, finally, let's put everything together, all the model guidance in the analogues to pull together the official DTN forecast. And here's the temperature outlook from May through to August, month by month. For May, it takes into account the chance of those colder outbreaks across Far Eastern Europe and Western Russia, subdued temperatures for parts of Iberia where it could be wetter. It also suggests cooler chances across Northern Europe, especially Scandinavia. In July, and seasonably cooler chances for Western and Northeastern Europe in August, with Northwest Europe also possibly a bit cooler to average, a bit closer to average. Unsurprisingly, this is looking familiar by now, for summer as a whole, we have temperatures widely above average across Europe. The strongest warm anomalies across South Central Europe and parts of Southeast Europe, especially the Balkans, and particularly the Northern Balkans. The probability of above normal temperatures is relatively high, although less so for Southwest, far Southeast and Northeastern Europe. But aside from those areas, this relatively high probability means reasonably high confidence in the forecast relative to the time frame. Risks to the forecast are more on the cooler side, maybe a 25% chance of less warm than currently expected, especially for Southeast Europe. The other scenario doesn't look much different to our forecast, so upside temperature chances might be limited. The forecast as it stands is suggestive of strong heat wave risks anyway, especially for parts of Southeast, Central, Southern and Eastern Europe, and particularly if drought conditions continue or develop. Now, breaking down the alternate scenarios, month by month looks like this. August has the coolest risks, but there's not really anything notable in the way of colder conditions at this stage. Sea level pressure anomalies look like this, where with our forecast on the top row, the analog composites on row 2 and the model blend on the bottom row. For May, there's a decent agreement on high pressure dominance, while some suggestions in June of some troughing in the UK and Ireland, but high pressure belts again during July, which we are expecting to be the driest month. Speaking of which, onto the rainfall forecast. In May, as the sub-seasonal outlook showed, Northwest Europe looks rather dry, but becomes wetter during June. Central, Eastern and Southeastern Europe, especially the North Balkans, look rather dry by July, when the dry areas should be expanding as high pressure becomes more dominant across the continent. So not only hot, most likely, but also drier than average, exacerbating drought and wildfire risks and impacting agriculture. On that subject, this is the precipitation across Europe during the past 90 days as a percentage of the climate normal. You can see how wet it's been for Iberia and patchily wet elsewhere across southern Europe, but a lot of dry weather in most other areas. And in light of that and of rainfall forecast expectations for the summer, there certainly are likely to be issues with drought and aridity, particularly in around the Balkans, maybe into parts of Central Europe as well. July could be the driest month, but there's a risk that existing drought conditions will help to push the frontal zone farther north, making even more of Europe drier and warmer earlier in the summer than currently expected. A reminder of the drought situation at the moment. Lots of watches, warnings, even alerts across Europe, especially Central to Eastern Europe and far Southeast in particular. And here's a rather coarse but potentially useful look at the Palmer Drought Index analog for March and for the June to August period, showing those drought risks for parts of Southeastern Europe there. For renewables, signals for summer as a whole are pretty blurred and washed out, so there's a lot of uncertainty, but unsurprisingly, those dry areas of Central, Southern and Southeast Europe, or at least where it's expected to be dry, are also likely to have the best solar output. This shows up better on a month-by-month basis wind power, June could be best for the UK and Ireland, while Central Europe is rather low. But by August, we could be seeing better winds for Western and Northern European mainland areas as the jet picks up. A quick plug, if I may, if you want to keep up with our updated seasonal forecasts as well as the sub-seasonals, as noticed earlier, then you can subscribe to our twice monthly seasonal forecast, so you're never left guessing. They're issued mid-month and late month every month. This is a snapshot of page 1 of our latest forecast issued last week. Not only that, these are augmented by detailed and expert climate notes and discussions every other week between the main forecast issues. So those are well worth getting your hands on. Finally, for the European forecast, a quick summary to absorb the most significant message. Just to reiterate, is for risks of unusually sustained periods of weather, potentially extreme weather like drought, strong heat waves and associated risks, especially for parts of Eastern and Southeastern Europe, although some strong heat spikes are possible across other areas of Central Europe and elsewhere. That's not all, though. With weather systems blocked up in peripheral areas, there'll be risks of prolonged rainfall, storms, major floods, with threats particularly maybe for Spain and Portugal if Eastern Atlantic low pressure just gets locked in there. Now, globally, the forecast looks like this. A lot of above average warmth across the Northern Hemisphere through the summer, particularly hot and dry through the central US and Canadian areas. Exceptions are subdued temperatures, where it looks abnormally wet through parts of subtropical Africa and throughout India, with potential for an active monsoon this year. The Southern Hemisphere, Australia, could have a seasonably cool winter with some wet chances in the east. Now that leads us on to the 2025 tropical outlook, courtesy of my colleagues in the US. This is useful knowledge because of the risk of ex-hurricanes and tropical storms recurving across the Atlantic and potentially impacting parts of Europe later in summer and into the autumn. So this is a look back at the 2024 season, which was pretty busy. 18 named storms, 11 hurricanes, 5 major, 5 named storm landfalls in the US, and nearly $130 billion of damage done, the third most costly year on record from hurricanes. But a quick glance at number of hurricanes per year, which can be a little bit misleading. There's not too much variation. Looks like an uptick in the 2000s, but some of that we think is probably due to better observing and monitoring, noticing more of these systems when they're out at sea. So here are the most important seasonal factors for the development of tropical systems and hurricanes. More likely when ocean temperatures are above average. We've seen a little bit lower than last year, but still above normal. When the vertical wind shear, excuse me, which is a change of wind direction and strength with height, if there's little change as we go up through the atmosphere, then systems can get organized. If there's high wind shear, systems can get torn apart, and we need large-scale rising air. If you have a stronger, wetter West African monsoon system, it can spit out disturbances and waves that can move across a favorable environment of the main development area. That's between the coast of Western Africa and the Caribbean Sea. So if you have warm waters and low wind shear where these waves and disturbances move across, then that's favorable for increased tropical development. The influence of ENSO during El Nino conditions tend to be less favorable for development. You can see from this table that El Nino years have fewer named storms than during La Nina or even neutral ENSO, which we're expecting this year, of course. That's because during El Nino, there's generally more wind shear across the Atlantic, so fewer chances of developments. But this year, of course, we're in neutral ENSO, so that's more favorable for developments. Looking at the analogs again, based on sea surface temperature patterns we've already seen, including 2012 as a pretty good match. Note the historical average of 14 storms, 7 named hurricanes and 3 major hurricanes. ENSO neutral years, overall average 16.5 named storms, 7.9 hurricanes, 3.6 major hurricanes, while our 2025 analogs, which includes 2012 as an average, just over 17 storms, just over 8 hurricanes, and 3 to 4 major hurricanes. So analogs suggest the probability of a slightly more active season than usual. And here are some of those analog years. And for our purposes, something they tend to have in common is the number of recurving storms across the Atlantic. So ex-tropical systems, ex-hurricanes could, or at least 1 or 2 of them, have some impact somewhere in Europe later in the season and into the autumn. You can see that signal also in the track density anomalies for the year, and likewise breaking it down month by month from August to October. The recurving potential shows up pretty nicely, and that's most noticeable in October, so beyond our seasonal forecast, but certainly something to bear in mind, and we're not ruling out some recurving storms occurring a little bit earlier in our summer. A reminder of the warmth of the seas across the Atlantic and the main development region, even though less warm than last year, so we can skip through that pretty quickly. Here are the tropical parameters, warmer Gulf, but somewhat cooler main development region waters and the MDR according to the CFS, although still somewhat favorable. Still a little bit above average, just less so than last year. And on the right, the wind shear forecast, which this model is showing as below average across the MDR, those blue colors, so favorable for developments, although less so in parts of the Caribbean. Here's the ECMWF named system forecast through October, which shows 16 storms overall, which is about average, and a few less than its forecast last year. I'll note that ECMWF failed to capture the 3 most active years, but 2025 is at least not looking to be that highly active anyway. The red line is what happened plotted against the past ECMWF forecast, so you can see those 3 other big misses there. So in summary, ENSO neutral is favorable. Analog years showing that above average tropical activity is most likely. The main development region is cooler than last year, but still a little above normal. Wind shear forecast to be below normal, partly due to the neutral ENSO conditions, also favorable for developments. So all in all, signals are suggesting a slightly above average tropical season for the summer of 2025, summer and autumn of 2025, I should say. And wrapping all that up, here's the DTN tropical outlook. And for our purposes, we should note the slightly enhanced chance of systems recurving across the Atlantic. Totals are similar to the analogs with 18 named storms, 9 hurricanes, and a risk of 4 major hurricanes. And that's our DTN tropical outlook. A quick look at, for interest, a quick look at the names on the list this year. So be on the lookout for Andrea as your first named storm of the season. Finally, the key messages to take away from all that. for the tropical season. Returning to our forecast for Europe and industry impacts, and indeed for other parts of the globe. For utilities, where most areas seeing above normal temperatures, there could be high energy demand for cooling, and there are chances of extended heat waves and strong heat spikes and dryness, especially in some eastern, southeastern parts of Europe, maybe more widespread at times, particularly during July. Above normal solar, especially for southeastern Europe, may mitigate things slightly, but winds aren't looking particularly favorable. While severe storms are going to be risked, as they so often are in summer, but especially later in the summer across southern parts of Europe and the Med, Iberian Peninsula. So power outages from wind and lightning, as well as localized gusts, that is, and squalls. Even severe storms, lightning and flash flood and aerial flood risks. Power lines potentially impacted by extreme temperatures. For aviation and transport, thunderstorms are always an issue, potentially causing delays at terminals, causing turbulence in flight. Strong heat can give issues on the roads, heat stress for outside workers, similarly for the railways, risks of buckled rails, and risks of low water levels, limiting barge traffic along the Rhine, for example. That could be something to watch out for. Levels were already slightly low, and that position could worsen through the summer. Public safety for all kinds of outdoor events, sporting, entertainment, and otherwise above normal temperatures, heat waves, increased risks for people to be affected by heat. Delays to outdoor activities through storms, lightning, strong winds, heavy rain. Aerial and flash flood risks could be a threat to property where any heavy rain producing systems linger. Offshore, impacts possible on shipping and the oil industry across the Gulf of Mexico, and indeed on transportation across the Atlantic. Could be delays in loading and exporting, and perhaps slower passage across the Atlantic through the summer. So that's that. That is our forecast for the coming summer. I hope that's given you some food for thought. And if anyone has any questions, happy to take any. Thank you.
Thanks, Stephen. If you do have any questions, feel free to put it in the Q&A feature. I do see we have one question. Why are North Atlantic sea temperatures so much lower this year compared with the record-breaking warmth of 2024?
Yeah, it's a good question. Well, the first difference is that in 2024 we were emerging from an El Nino with equatorial Pacific temperatures, sea surface temperatures dropping pretty steadily. Now that meant reduced trade winds across the tropical Atlantic, and that allowed warm seas to pile up eastwards, as it were. But this year we've had La Nina now shifting to a neutral ENSO state. So that's basically the fundamental difference there is in the strength of the trade winds across the Atlantic. And it illustrates how there can be a linkage across oceans where warm waters develop late winter and spring in the Far Eastern tropical Pacific near the coast of South America. And that altered the atmospheric circulation patterns and caused trade winds to pick up across the tropical Atlantic. And that brought some cool upwelling across the main development region, as we saw. So the bottom line is increased trade winds compared to last year, cooling the tropical Atlantic. Although the main Atlantic basin's temperatures are not so much different from last year. And in any case, we should see an overall rise in sea surface temperature anomalies through the summer as those trade winds likely weaken.
Great, thanks. I don't see any other questions coming through, and we are just about at the top of the hour. So I want to thank Stephen for presenting what we can expect for the summer season in Europe and the UK. And as I said, when we kicked off, I will be sending out the recording to this. Probably early next week, you will see it in your inbox. So with that, I want everyone to have a great rest of your day, and you can now disconnect. Thank you.